Okay, let's have a little look at the Mymaths homework for arithmetic sequences. So, question 1. Tick the arithmetic sequences. You must get more than 4 correct to get marks. Okay, so after the lesson, we should have recognized that arithmetic sequences are sequences that go up or down by the same amount each time. So the gap between the numbers has got to stay the same. So if I have a look at this first example, so I've got a gap of 6, another gap of 6, another gap of 6, so that would make it arithmetic. Now this one goes down by 3, well, then it goes up by 6. Now even if it went up by 3, the fact that it went down first and then it goes up means that this one is definitely not an arithmetic sequence. So this one goes up by 2, but then it goes up by 6, so that one is not arithmetic. This next one goes up by 3, then it goes up by 4, so this one isn't arithmetic. This one goes up by 2, then 2, then 2, so that one is. This one goes up by 2, then it goes up by 3, so that one isn't arithmetic. This one goes up by 3, up by 3, up by 3. The gap's the same, so that one's arithmetic. And this one goes down by 5, down by 5, down by 5, so that one would be arithmetic. Okay, find the first 5 terms of the patterns with these nth terms. So an nth term rule is something that will generate a sequence. So this rule says our sequence is going to be made by 3n plus 9. So n represents the position in the sequence. So n is going to be 1 for the first term, 2 for the second term, 3 for the third term, 4 for the fourth term, 5 for the fifth term. So this says that we need to do 3 times the position, add 9. So we're going to replace n with a different position number each time. So we're going to start with n being equal to 1. So this means 3 times 1 plus 9. 3 times 1 plus 9 would be 12. Then n is going to be 2, so 3 times 2 plus 9 is going to be 15. Then 3 times 3 plus 9 is going to be 18. And I can actually fill in the rest without working them out. And how I've done that is, I will have noticed that this sequence is going up in 3s. It actually goes up in 3s because of the 3n part of the rule. Looking at the next one, nth term is 8n take away 6. So exactly the same again. N is going to be 1, then n is going to be 2, then n is going to be 3. So I'm going to do 8 times 1 take away 6, which is 2. Then I'm going to do 8 times 2 take away 6. So n is going to be 2 this time. 8 times 2 take away 6. That's going to be 10. Then 8 times 3 take away 6. That's going to be 18. And once again, I am going to go about filling in the rest of the numbers seemingly by magic without working them out, because I know this time my sequence is going to be going up in 8s because of the 8n part. The 8n part gives me like an 8 times table. 8 times 1, 8 times 2, 8 times 3, and so on. Which means I'm going to have a sequence that goes up in 8s. So that's how I was able to work out the last 2 terms quite quickly. Right then, this bottom question, write down a formula for the nth term of these patterns. The first term is n equals 1. Okay, so we've got a sequence here. It goes 13, 20, 27, 34, 41. So the way in which we work out an nth term is the first thing we need to look at is how much our sequence is going up or going down. Now, to actually help with this question, I'm actually going to go over to a different page here. So I've got 2 sequences I'm going to be finding the nth term for. So here is the first one again. So 13, 20, 27, 34, 41. So first thing we should be able to notice is that we are adding on 7 each time. So 13 plus 7 gives us 20. 20 add 7 gives us 27. 27 add 7 gives us 34. 34 add 7 gives us 41. So this sequence goes up in 7s. So what that tells me is it has something to do with the 7 times table. So the 7 times table is made from the rule 7n. Now, if I write down the sequence for 7n, it's just going to be the 7 times table. 7 times 1, 7 times 2, 7 times 3, 7 times 4, and 7 times 5. So that would be my 7 times table. What I'm going to do though is now say, right, well, this is my 7 times table using the rule 7n. How do I get from the 7 times table to the rule that to the sequence that we have down here? Well, 7 add 6 gives us 13. 14 add 6 gives us 20. 21 add 6 gives us 27. So this is actually the 7n rule plus 6. So it's exactly the same as the 7n rule, but with an extra 6 added on. And I can do a little check to see if that's correct. So 7 times 1 add 6 gives us 13. 7 times 2 add 6 gives us 20. 7 times 3 add 6 gives us 27, and so on. So my first answer is going to be 7n plus 6. I'm going to write that in here. Okay, for the next sequence. So next sequence is -2, -8, -14, -20, -26. So the first thing we're going to recognize here is there is a gap of 6 between our numbers. We're going down by 6 each time. So -2 take away 6 gives us -8. -8 take away 6 is -14. -14 take away 6 is -20. And -20 take away 6 is -26. So I know that this sequence has got something to do with the -6 times table. Now the -6 times table is just the same as the 6 times table, but with negatives. So -6 times 1 is -6. -6 times 2 is -12. -6 times 3 is -18. Then -24. Then -30. So this is the sequence for -6n. How can I get from this sequence to the sequence that we want? Well, hopefully, just having a little look, you can see that I've got a gap of 4. If I add on 4 to the top numbers, that will give me the sequence that I have below. So our sequence is the -6n sequence plus 4. And once again, we can do a little check to see if that's correct. So -6 times 1 add 4 gives us -2. -6 times 2 add 4 gives us -8. -6 times 3 add 4 gives us -14. And so on. It does check out. So our answer, our rule for this particular sequence is -6n plus 4. -6n plus 4. Okay, I'm going to click mark it, and thankfully we've done really well on this one. 15 out of 15, good stuff. Let's have a look at question 2. Looking for patterns. So we have some blue beads and black beads. Hopefully we can see a pattern, which each of these sets of beads. So how many blue beads would there be in pattern 5? So let's focus on the blue beads in each of these little pictures. So our blue beads starts off with 4, then there are 6, then there are 8, then there are 10. Our blue beads seem to be going up in 2s each time. Notice how we've got an extra pair of beads, blue beads, added on. So for pattern number 5, that would take me up to 12. What you could do, I've not done it here, but what you could do is draw a little picture to help you out. How many black beads would there be in pattern number 5? Well, the black beads seem to be going up in 3s. Notice how there's an extra line of 3 black beads each time. So we've got 3, 6, 9, 12, So I predict that in the next pattern there would be 15, add in an extra 3. Write down an nth term formula for the number of blue beads. Okay, so the number of blue beads starts off with 4, then there's 6, then there's 8, and then there's 10. What I'm going to do, I'm going to go on to a bit of paper to do some working out. So it started with 4, then there was 6, then there was 8, and then there was 10, and then we predicted that after that there would be 12. So this is my sequence for blue beads. So notice how it's going up in 2s each time. So add 2, add 2, add 2, add 2. That tells us that the rule has got something to do with the 2 times table, which has the rule 2n. So that 2n will give us the sequence 2, 4, 6, 8, 10. And just space it out so all my numbers line up. So that's my 2n sequence. How do I get from the 2n sequence to the sequence that we have? We need to add on an extra 2 each time. Add 2, add 2, add 2, add 2. So the rule for the blue beads is going to be 2n plus 2. So I'm going to bring that up. I'm going to write in 2n plus 2. What is the nth term for the black beads? So we've got 3, 6, 9, 12. Let's just write that on my working out page. 3, 6, 9, 12. And then we predicted that pattern number 5 would have 15. So our pattern is going up in 3s each time. So plus 3, plus 3, plus 3. So I know it has something to do with the 3 times table. So it's going to involve the rule 3n. So what is the 3n sequence? Is that going to look like it's 3 times 1, 3 times 2, 3 times 3, 3 times 4, and 3 times 5? Well, look at that. That's the sequence that we have. So we just got the 3 times table, which means our rule is simply going to be n. How many blue beads would there be in pattern 22? So we want to know what is going to be the 22nd number in our sequence for blue beads. But let's just go back to our working out. So for blue beads, we have this rule here, 2n plus 2. And for the first pattern number, there was 4, then there was 6, then there was 8, then there was 10, then there was 12. We need to use this rule to find out how many blue beads there are in pattern number 22. Now, pattern number 22, what this means is n is going to be the value 22. So I'm going to use this rule, 2n plus 2, and I'm going to replace n with 22. So I'm going to do 2 times 22 plus 2. So I've replaced n with 22. 2 times 22 is 44. Add 2 is 46. So I'm going to put in an answer of 46. How many black beads would there be in pattern 62? So I'm not actually going to do these last two here. I'm actually going to let you have a go to working out how to do the last two yourself. To work out the number of black beads in pattern 62, we would use the rule for black beads, and we would focus on this value of 62 in some way. See if you can figure out what you would do there. And then finally, how many beads would there be altogether in pattern 46? It seems like it would be a good idea to work out how many blue beads there would be in pattern 46, and then how many black beads there would be in pattern 46, and maybe add them together. Let's just mark what we've done so far. Got lots of ticks there, looks pretty good, and that's how we tackle the homework on arithmetic sequencing.